Hey, we're going to work a problem, and we're going to do it both using the disk washer method and the shell method. It is rotate the region contained by y equals 3x, y equals 0, and x equals 2. And we're going to rotate that around y equals 7. So I've already graphed this, and it looks like a triangular region in the first quadrant. So y equals 3x, of course a regular sloped line, and then bound by the x-axis and x equals 2. And we're rotating that around y equals 7. So I'm going to start off by using the washer method, since there will be a gap between y equals 7 and the figure from what you see here. So washer method, and since we're going around something parallel to the x-axis using the washer, we'll write everything in terms of x, so our whole integral needs to be in terms of x. So remember with the washer method, it will be pi times the endpoints, integral of the endpoints, outer radius minus inner radius. So looking at this from the line y equals 7 out to the outer radius would be the full 7. It would be from 7 back to the x-axis, it would be the full 7. And the inner radius would be the 7 take away what's under 3x. So 7 minus 3x would leave us the inner radius. So when we plug those in, we'll have pi, and it'll be from 0 to 2, the integral, of 7 squared minus the quantity of 7 minus 3x squared dx. We'll fold those out, collect like terms, and we'll have pi times the integral from 0 to 2 of 42x minus 9x squared dx. Integrate that. Pi times the quantity 21x squared minus 3x cubed, evaluated from 0 to 2. When you plug 2 in, you get pi times 84 minus 24. When you plug 0 in, you get 0. So the final answer is 60 pi. Okay, and we did that using the washer method. So we're going to do the same thing using the shell method. So I have the same figure, the same region, and we're still going to go around y equals 7. But when we use the shell method and we go around something parallel to the x-axis, we're going to write it in terms of y. So everything needs to be in terms of y. So remember that the shell method is 2 pi times the radius times the height. So that's what we need. So 2 pi, and my endpoints for this will be from 0 to 6 for y. That is what the triangular region will cover, 0 to 6. The radius from y equals 7 out to some y point will be 7 minus y. So if I pick my y to be 2, the distance from the radius to that y of 2 would be 7 minus 2, or 5. So that's my radius coming out to any point. And then the height would be parallel to the x-axis here. So it's always 2 on the right hand side, but the y equals 3x is the left hand side, but we need that in terms of y, so I rewrote it as x equals 1/3 y. So my height here is from 2 take away 1/3 y. Okay, so plugging all that in, I have the integral of 2 pi from 0 to 6 of 7 minus y for the radius times 2 minus 1/3 y for the height dy. I can fold that out and collect like terms. I need to move my face, so let me put myself in this corner. And when I collect like terms, I have 2 pi times the integral from 0 to 6 of 14 minus 13/3 y plus 1/3 y squared dy. The integration of that will be 2 pi times the quantity 14y minus 13/6 y squared plus 1/9 y to the third from 0 to 6. And then when I plug in 6 for y, I get 2 pi times, it looks like about 60 when I evaluate it. And when I plug in 0, I get 0. So once again, using a different method, as long as I do it correctly, I still get a volume of 60 pi. Alright.